Welcome to part two of solving algebra equations. Today is the subtraction addition, which is just an extension of what we learned about last class, addition. Again, we'll take you to the learning goal today. I can solve algebra equations that involve subtraction. Like I said, last class we talked about how to solve the addition style questions, and I'm going to take you through one example of that just to refresh your memory. But today the focus is on subtraction. Questions that look like this: x minus 2 equals 5. It has a subtraction sign in it today, and so that becomes our focus. Before we get into that though, let's have a look at what we learned last class about how to solve addition style problems. If you remember, we talked about how you want to get this mystery bag all by itself, and right now it's not by itself because it's crowded over with this plus 4 on this side as well. And so we talked about how to get rid of those 4. You're just going to use the opposite operation of addition, which is subtraction. We just want to subtract these 4 items off of the left side in order to maintain equality, in order to keep this machine in balance. That means we also want to subtract 4 from the right side. Now I don't have this all prepared, but I'm just going to do it the old-fashioned way here. Scribble these 4 out, and then I'm also going to scribble these 4 out. And that leaves me with my answer. It leaves me with only the mystery bag, or my variable x, on the left side. And on the right side, we have 4. So there you have it. Quick little review that took less than a minute. So that's painless. Today we're going to move into subtraction style questions though. Now I'm going to point out a few differences on how this is represented. If we go back to this question, actually, if we have our mystery bag plus 4, it means that we have our mystery bag here, but we're also adding some more weight to this side. With a subtraction style question though, we are taking away 4, and so we're not adding, we're not making this side of the balance heavier, we're actually making it lighter. So to represent that, I have 4 helium balloons. These balloons will pretend are filled with helium. If we tied them to this balance here on the left side, they would actually pull up on the balance, making it lighter. And that's in effect what we're doing with subtraction. We're reducing the weight, or reducing the value on that side of the equation. So this would look like this. We still have our mystery bag, but now we have 4 balloons lifting up on that side, making it even lighter. But what this is telling us is that all of this on the left side is equal to 2 of these black weights on the right side here. So here's what we're going to do. Here's how we're going to look at this today, is that rather than subtracting or getting rid of these helium balloons, we're just going to tie counterweights onto the bottom of them, onto the string. And so the balloon is going to want to lift up, but the counterweight is going to want to pull down. And when we pull up and pull down with the same amount, it has a net weight of 0, or I guess another way of saying that is that they cancel out. And so check out what I'm going to do here. I'm going to add 4 counterweights onto the left side of my scale over here. Mathematically, what I just did there is I added 4 to the left side of my scale. And remember, it's no longer equal anymore because I have added weight to one side but not to the other. So again, let's keep this in balance. We're going to add 4 to the other side. So we'll just click on down here. So we've added 4 to this side. We've added 4 to this side, to the right side now. And now my balance is level again. It's equal. But the thing is, now I have all 4 of my balloons attached to counterweights here. And when we do that, like I said, something cool kind of happens. They disappear. So really, all I'm left with now is my mystery bag, and that's exactly what we're trying to solve for. We're trying to figure out how much this weighs, or what its value is. And because it's in balance with the other side here, I know that it must equal 6. So I'm just going to scroll down here. All right, so let's just kind of review what we just did there. Our initial problem was x minus 4 equals 2. We didn't want these 4 helium balloons, so we added counterweights. but that means we had to add those weights to the right side of the equation as well. Those balloons canceled out, leaving me with only an x on the left side of the balance. But of course, if we add our original 2 weights to the 4 that we put on there, that gives us a value of 6. And voila, we've solved our problem. Let's do one example here without the balance, the visual there to help us out. But on this side, we have 3 helium balloons here, 3 negative weights. And to get rid of those, we want to put 3 counterweights, or we're going to add 3 weights to the left side of the equation. But if we do that, of course, we have to add those 3 weights to the right side of the balance as well to maintain our equality. Now, again, I would love to see this when you're showing your work on your assignment for today, showing me by striking this out that the -3 and the +3 just cancel each other out. And then down below that on a new line, you should show me that you still have your x left over, your variable. And then we can combine what we have on the right side here. We started with 14, but we've added 3 more, and that should give us 17. X equals 17 is the correct answer to that question. All right, guys, we'll see you on the next slide where you can find your assignment for the day.